Hello students, once again welcome to Akshar IIT classes and I am your chemistry faculty S. Mohan. In the previous classes we discussed how to write the chemical formula of a given compound, right? So we discussed like if one compound is there, how to write the chemical formula. For example, sodium chloride. We discussed sodium and chlorine, we write their valences and crisscross, so we can get the formula that we discussed. And we also discussed some big compounds also, like for example if you want to write the calcium phosphate, so this also we discussed. If you want to write the calcium phosphate formula, first we write the calcium Ca and then we write the phosphate PO4 and we write the valency 2 and we write the valency of phosphate 3, then we crisscross, then we can get Ca3PO4 taken twice. So this is the formula, this we discussed, right? And we also discussed if the compound is given, how to give the name. Yes, so this also we discussed. What is the name of this one, for example. So here we know this is a metal and this is a compound, so the metal name is what? Calcium, so we write the calcium, and this is phosphate, okay, phosphate. This also we discussed. If two non-metals are there, then how to write? For example, SO3 is there. So if we want to give the name, so this is also non-metal, this is also non-metal, so we write the sulfur, and this is what? Oxide. But when two non-metals are there, you have to mention the number. So tri. How many oxygens are there? 3 oxygens, trioxide. So this all we discussed in the previous classes, and I hope you might have practiced this one. Okay. So we are completed till synopsis 7 in the previous class. The synopsis 7 we discussed how to name the compounds, right? Now in the synopsis 8 students, we have the oxidation number, a topic is there. This topic we are not going to discuss now, right? Why? Because this topic requires some other basic concepts. So this topic we are going to discuss in the mole concept chapter. Okay. So now we are going to move directly to the synopsis 9. Where you are going? Synopsis 9. Okay. So now students, open the synopsis 9 topic, that is chemical equations. So students, today I am going to discuss about the topic called chemical equations. This is synopsis 9 in your textbook, in your material. Okay, that is chemical equations. Alright, so our main chapter is language of chemistry. Language of chemistry. Clear? So students, now we are going to discuss about the chemical equation. Listen carefully, very important topic, and this is very essential to learn the chemistry. So the chemistry, first part, learning about the elements like alphabets in the language, that we are completed, and then making the words like if you know the language like English, first you read the alphabets A B C D like this, and then next what you do, you can make a small words like APP, LA, apple, BA, LL, ball like this. So that also formation of compounds we completed. Now we are coming to the main concept, okay, that is like sentences. Okay, so here we are going to come across the chemical equations, right? So what is the chemical equation? Chalo, before going to the chemical equation, first let us discuss about the chemical reaction. Discuss about chemical reaction. So chemical reaction means what? Here when the two substances combined chemically, then that is called a chemical reaction. For example, if you burn the wood or paper, anything, if you burn in air, so what happens? It forms an ash, right? And a smoke comes out. So similarly, when you burn the carbon in oxygen, you'll get what? Carbon dioxide. What will you get? Carbon dioxide. So carbon is combining with oxygen, is reacting with oxygen. Combining means what? You're reacting with oxygen and forming carbon dioxide. Okay. So like this. So these are called chemical reactions. So many things. Okay. Might have learnt in the in the science only biology. Like we take oxygen for respiration, right? And we exhale the carbon dioxide. Yes or no? We intake our oxygen and exhale carbon dioxide. So here oxygen is converting into the carbon dioxide. Is this clear to you? So these all are chemical reactions. Okay. So here chemical reaction means what? When two elements or compounds will combine with each other, will react with each other. So see students here, for example, carbon. Carbon burns in air, okay, to form carbon dioxide gas. Okay, so this is one chemical reaction. Carbon burns in air to form carbon dioxide. So like this, we come across in the chemistry some millions of reactions. How many? Millions of reactions. So for every reaction, it is difficult to write like this a big sentences, right? So what we do, we make it short. We make it short. So the same chemical reaction, we can write in short just by using the symbols and formulas. Like you see here, carbon. Symbol is what? What's the symbol of carbon? Good. C. Burning in air. So burning in. Instead of burning in, what we are doing? We are putting the plus. Means reacting. Air. Air means what? Air we take oxygen. Okay. So oxygen. Oxygen formula is what? O2. To form. For to form we are giving arrow mark. Means it's forming. What is forming? Carbon dioxide. CO2. Carbon dioxide formula you know. Okay. Gas. So we put one arrow mark like this. Then why? Generally gases move upwards, right? So here this big reaction, this one sentence, and simple, okay, by using symbols and formulas we written in short. So this is called a chemical equation. What it's called? A chemical equation. This is called a chemical reaction. And the same reaction we are representing by using the symbols and formulas in short. That is called a chemical equation. Clear to you? Yes. So chemical reaction, chemical equation. Right. Now this is called a chemical equation. So in this chapter we are going to learn about this chemical equations. Writing of chemical reactions in short by using the symbols and formulas is called a chemical equation. The definition is there. This is the definition. Okay. Representation of a chemical reaction in short by using symbols and formulae. That is called a chemical equation. Clear? Any doubt? No? Sure. Now, see students here, carbon symbol is C, correct. Air is means oxygen, O2 correct, and CO2 correct. Okay. Now, here how many carbons? Such one important thing here. Here carbon is reacting with oxygen. So, carbon is reacting with oxygen. These are called reactants. What these are called? Reactants. Okay. And we are getting after the reaction we are getting a new substance. That new substance is called product. What it is called? Product. Okay. So what we are making to react, that is called, they are called reactants. What we get here, that is called a product. Clear to you? So reactants and the products. Right. A mom cooks rice. So she'll take the raw rice and she'll add the water and she'll boil. Right. So then what happens? We can get the boiled rice that we eat. Okay. So here what we are taking the first initially raw rice and water. So these are called reactants. Okay. And next what we are getting after cooking? Boiled rice. Okay. Which we can eat. Okay. So that is a product. Clear to you? So whatever reacting, combining, they are called reactants. Whatever we can what is formed after the reaction are called products. If two or more products or the reactants are there, we join with the plus. Similarly, if two or more products are there, we can join with, here also we can write plus. Okay. Next, reactants should be written on the left side. So, see I am starting like this. So, here reactants are towards my left side and the product is towards my right side. So, when you write, so reactants you have to write towards the left side and products you should write on the right side. And this reactants and product are combined, means joined with this arrow mark. Okay. And the head of the arrow mark, so this is head of the arrow mark should point the product. These are the some rules, okay, conditions to write the chemical equation. Clear? Any doubts? So, what these are called? Reactants. What a new substance is formed is called product. The reactants are more, should add with the plus. If the product is more, here also should add with the plus. And where the reactant should be written? Left side. Where the product should be written? Right side. Reactant product should be joined with arrow mark. Clear? So, these are the some conditions to write the chemical equation. Okay? Yeah? Okay. Now, see students, very important point I am going to explain you. Now, see here. Now, here I have taken one carbon and two oxygens in the reactants. One carbon, two oxygens. Okay? O2 means what? Two oxygens. Now, in the product side, you see, one carbon, two oxygens in carbon dioxide. Yes? So, this is absolutely right now. It's perfectly correct. It's perfectly correct. 100% correct. Okay? Sure. Now we go to some other reaction. Okay, so other reaction is, now instead of carbon, I will take the magnesium. Instead of carbon, I will take magnesium. Okay? So, magnesium burning in air, burning in oxygen. So, I am putting plus. Plus means what? Burning in oxygen. So, I am writing oxygen, burning with oxygen to form. So, instead of putting to form, I am writing arrow mark and it forms a magnesium oxide. Magnesium oxide. This is my chemical reaction. This is what? My chemical reaction. Now, I want to write the chemical equation for this reaction. Means I want to make it simple. Okay, by using symbols and formula, I want to write the chemical equation. So, students, come on, tell what is the symbol of magnesium? Loudly. Very good. Mg. So, Mg is a magnesium symbol. Oxygen. Here just already done O2. So, wherever you get the oxygen, you have to write the oxygen O2. Right? Now, I want to write magnesium oxide formula. You know how to write the formula. So, here magnesium oxide means what? What I should do? First, I write the magnesium, then I write the oxygen, then I write the valency of magnesium, that is +2, and oxygen valency, that is -2. So, now I need not to use these symbols, and if same number are there, you can cancel. So, the formula is MgO. This already you practiced. Practiced or not? Practiced. Very good. So, now, so magnesium oxide formula is MgO. MgO. Okay. So, this is the MgO formula. So, now this equation I written in the form of chemical equation. This reaction I am written in the form of equation. So, magnesium symbol Mg. This is absolutely correct. Oxygen formula O2. This also correct. When magnesium reacting with oxygen, it is forming magnesium oxide. Magnesium oxide formula MgO is also correct. Now, if you write this chemical equation, okay, for this reaction in your examination, okay, your teacher will not give the mark to this equation. Your teacher will not give the marks to this equation. Now, the question arises, why? Yes, sir, magnesium symbol is Mg, I written correct. Oxygen formula is O2, yes, I written correct. Magnesium oxide formula, you said that MgO, I have written correct MgO only. Then why teacher cannot give the marks to me? That's your question, right? Chalo, I'll explain that now. Now here you see students, here how many magnesiums are there? No number is there, means what? One magnesium. So here how many magnesiums are there? One magnesium only, no number. Now here how many oxygens are there? Two oxygens. But here how many oxygen is there? One oxygen. Then here 2 oxygen is 1 oxygen. Where that 1 oxygen went? Where that 1 oxygen gone? Yes. So that's what your teacher will not give the marks here. Clear to you? Okay. So now, then what we need to do to get the marks? Then you need to balance the equation. What you need to do? Balance the equation. Balancing means what? How many atoms are in the reactant side, left side? The same number of atoms should be present even in the right side also. That is called balancing. Okay. So balancing means what? How many elements or atoms are reacting in the left side? The same number of elements or atoms should be on the right side also. Then we can say that is called balancing of equation. This is actually based on one law which is called as the law of conservation of mass. That is called what? Law of conservation of mass. Law of conservation of mass states that mass can neither be created nor destroyed. Mass can neither be created nor destroyed. So here during the chemical reaction, when it comes to the chemistry, the total number of elements, otherwise you can say the total mass of the reactants should be equal to the total mass of the products in chemical reaction. Okay, means what? The total mass of the reactants and products should be same in the chemical reaction. Clear to you? Means what? Total number of atoms present in the left side, means in the reactants, should be equal to total number of atoms present in the right side also. That is called law of conservation of mass. So law of conservation of mass, what it says? The mass can neither be created nor destroyed. The total mass of the reactant should be equal to total mass of the product. The meaning is what? The total number of elements or atoms towards the left side is equal to total number of atoms or elements in the right side also. But here it's not getting balanced, not same, right? So such reaction, okay, this reaction if you see word-wise, magnesium correct, oxygen correct, magnesium oxide formula is also correct. Word-wise it is correct, okay, and but overall it is not correct. Overall it is not correct. So this is called a skeletal equation. What it is called? Skeletal. Okay, skeletal equation. So what we write by using this chemical reaction, as is what we write, that is called a skeletal equation. Okay, now it is also called unbalanced equation. It's not balanced. Okay, we need to balance it. Okay, so how to balance, students? Now I am going to explain you how to balance. So listen carefully here. Here there is no one particular method is not there to balance the chemical equations. So means there are some methods out there, but you learn in higher classes. Later I will explain you. But here we use the method called the hit and trial method. Which method? Hit and trial method we use. So what we use? So see here now. Here we have one magnesium. Here we have one magnesium. Right. Here two oxygens are there, but here only one is there. Okay. So I have to balance these oxygens first. So to balance oxygen, I should not write here 2. Here 2 is there, so I can write 2 means no. We can't write because magnesium oxide formula is MgO, not MgO2. So that what we have to do? Now first magnesium is 1 and 1. It's okay. But oxygen is not balanced. So first you balance the oxygen. Okay. So to balance oxygen. Okay. To balance oxygen. So what you need to do? See students here. Can you see here? So here I am writing Mg plus O2 gives rise to what is there? MgO is there. But here oxygens 2 are there. Only 1 is there. So to balance that you have to write the 2 in front of MgO. Okay, 2 you should write here. Don't write the 2 here. If you write the 2 there, the formula becomes wrong. So you have to write the 2 here in front of this one. This is the first step. So here 2 oxygens are there. Here 2 oxygens are there. Yes, it's balanced. Right. But see now. Here as you written 2 in front of magnesium oxide, now magnesiums also became 2 now. But here we have only one magnesium. Yes or no? Now balance magnesium now. Can you see now? Balance magnesium. Okay. To balance magnesium, what we do? Okay. Just we write it 2 in front of this one. Okay. So I am writing like this. Can you see here? If not, here only I'll write. So here I am writing 2 now here. Okay. So now what happens here? 2 Mg, 2 magnesiums. Here you see 2 magnesiums. Here 2 oxygens. Here 2 oxygens. So now it is balanced. It is balanced. Clear to you? The total number of atoms in the left side, means in the reactant, should be equal to total number of atoms in the product side. So this is called a balanced equation. Clear? So if you write like this equation, if you write in the examination for this reaction, then your teacher, if it is 2 marks, means your teacher will give 2 marks. No doubt about it. Clear? So whenever you write the chemical reactions into equations, you have to write the balanced equations only. You have to write what? Balanced equations, not a skeletal equation. Skeletal equation. This is called skeletal equation. Okay. If you should not write the skeletal equation. You have to balance that skeletal equation. Then you write the balanced equation. Is this clear? So see here, magnesium Mg, oxygen O2, MgO. Okay. Once again I'll explain you. So this one here, same thing. Once again, in one step only I'll explain you. At one place only I'll explain you. So here you see now, one magnesium is there, but here 2 oxygens, here only 1 oxygen. So don't write this side like this. This is wrong method. Always you have to put the number in front of. So here 2 oxygens are there, only 1. So that's what write here 2. Right here 2. Clear? Now if you write 2 oxygens, here 2 oxygens balanced. But now magnesiums you see here, it become 2 magnesiums, but here only 1 magnesium is there. So to balance that, you write 2 here over 2 magnesiums, 2 magnesiums, 2 oxygens, 2 oxygens. This is called balanced equation. Clear? Okay. This is the way of balancing the equation. Right? Okay. If you want to copy this one for 1 minute. Okay. Then I'll explain you 2 more reactions. I'll explain you how to balance it. Okay. Copy now. This I will rub now. Okay. Here I'll write the third equation, some other equation. So now see third equation, what I am writing is hydrogen plus chlorine, other than write oxygen, to form water. Right. Is this you copied? Now you see this one. Hydrogen. See, hydrogen is diatomic molecule. Wherever you have to write hydrogen, you have to write H2, not O2. Okay. So H2. So I am writing H2 plus oxygen, write O2, gives rise to write water formula. You know that H2O. This is the hydrogen correct, H2, oxygen O2 correct, water H2O. This is also correct. Everything is correct. But overall, whether it is correct or wrong, overall it is not correct. Why? What I said, the equation should be balanced. Means what? Total number of atoms towards the left side and right side should be same. Now let's check here. 2 hydrogens left side, 2 hydrogens right side, balanced. 2 oxygens left side, but only 1 oxygen in the right side. Is it balanced? No. Right? Now you have to balance. Okay? So how to balance? Stepwise. I'll explain, listen. Shall I do here only? Shall I? Okay, I'll stepwise explain you. So see here now, I'll write H2 plus O2 gives rise to H2O. So I said that 2 hydrogens balanced, but here 2 oxygens, only 1 oxygen. So what I said, can I write 2 here? No, students, that is wrong method. Okay, you should not write 2 here. What I said, should write in front only. So write 2 like this. Clear to you? So now see 2 oxygens and here 2 oxygens. Yes, oxygen is balanced. After balance the oxygen, you have to check whether the hydrogen is balanced or not now. Initially it was balanced. Here 2 hydrogen, 2 hydrogen. But here you see now, because you written one number. So you have to check now. So here 2 hydrogens are there, but here 2 2s are 4 hydrogens. See, 2 like this 2. So 2 2s are 4 hydrogens are there. So now it is not balanced. So now we have to balance the hydrogen. So here 2 2s are 4. So here we have a 2. So by which number we shall I multiply this 2 to get the 4? 2 2s are 4. So now in the next step, what I do is H2 plus O2 gives rise to 2H2O. This step only. So here 2 2s are 4 are there, but here only 2 is there. So what I do, I should multiply with the 2 here. Now 2 2s are 4, 2 2s are 4, 2 oxygens, 2 oxygens. Yes, it is balanced. Both the sides same number of atoms are there. So this is balanced. Clear to you how to balance? Right? Chalo, copy this one. Now, last and final one. One more I'll explain you. After that, okay, I'll explain you some limitations of this balancing of equation. Right? Now, one more. Here I am writing the fourth one. So, here nitrogen plus hydrogen gives rise to ammonia. Okay. So first step I'll write nitrogen formula is N2, hydrogen formula is H2, and ammonia formula is NH3. Now try to balance it now. So see here 2 nitrogens here, but here only 1 nitrogen is there. Here 2 hydrogens are there, but here 3 hydrogens are there. So it is not balanced. Now can you try balancing of equation this one? Come on, try now. Try everyone. First write this equation N2 plus H2 plus NH3. Then see here how many nitrogens are there? Left side 2. But here how many nitrogens are there? 1. So what we need to do? Write 2 here. Okay. So see here directly I am writing here. Okay. So write 2 here. Right? So 2 nitrogen balanced. Okay. Now see here how many hydrogens are there? 2 hydrogens. But here you see this 3 and this multiply, you should multiply this one. 3 2s are 6. Here 6 hydrogens are there. 3 2s are 6. But here only 2 is there. So with what number shall I multiply this 2 to get the 6? 3. So I am writing 3 here. Okay. Now 2 nitrogens. 3 2s are 6 hydrogens. 2 3s are 6 hydrogens. Now it is balanced. This is called balanced. Both the side, the number of atoms are same. Clear to you? Right? Any doubt? No? Chalo. So this is called balancing of equation, and students you can practice some more equations. Okay. Now here, this is balancing of equations. Here there are some limitations over there with balancing. Limitations means what? Drawbacks. So in this balancing of equation, if you write as it is, so many things are there. Okay. So for example, if you return this equation, for example, nitrogen, hydrogen react to form ammonia. If you return this one. But I know that nitrogen is a gas, yes, present in the atmosphere. Hydrogen is a gas, that also I know. But I don't know ammonia, what is it? Whether it's a gas or solid or liquid. Right? Similarly, you see hydrogen is a gas, oxygen is a gas. And if I write only H2O, if I don't know the formula of H2O is a formula of water, then I don't know what is the state of this one. Yes or no? So here, we don't know what type of substances, whether solids or liquids or gases. We don't know what type of substance are reacting and what type of substance are forming. Means what? We don't know the states of reactants and states of the products. Okay. So just if you write like this. That's the first thing. Second thing, we don't know what conditions are required to make this equation. Means to complete the reaction. Okay. So if I, for example, I told you that if I take the rice, raw rice, uncooked rice, and I put the water, so I'll write like this. Okay, raw rice plus water, okay, gives boiled rice like this. Okay, I'll write like this. For example, you think. So here rice is mixed with water. So I'm mixing with water and keep there. I don't know other condition. Here heated, not heated, nothing is given here. I don't know. So I'll put there. Yes, I'll put the water in the raw rice and put there. Okay. Can I get can the rice will be cooked? Can I get the meal ready? No. we have to boil it, you have to heat it, means boil it, so that rice will be cooked. So I get my meal. Is this clear to you? So we don't know that conditions. Yes or no? So that's what, due to these limitations, okay, it was suggested that whenever you write the chemical equations, you have to make some more informative. The reaction should be more informative. So whenever any person can see your chemical equation, then he should understand, okay, so what were the things, what is the state, what is these all things. Okay, so that's what, for example, you say hydrogen. Okay, so hydrogen is a gas. So what you have to do, just you put the G here. So hydrogen is a gas. So you are representing like G. Okay, oxygen, this also G. Okay, here it forms actually water vapor. Okay, if you want to write if it's a water liquid, then you can write L, liquid, to represent like this. Okay, nitrogen is a gas, hydrogen is a gas, and it forming ammonia, this is also a gas. So if you can write like this, it will be better. Okay, now previously one more reaction I said is that carbon burns in oxygen to form carbon dioxide. So carbon is what? A solid. Oxygen is what? A gas. Carbon dioxide is also gas. But what happens when carbon we are burning in oxygen? What happens? The heat is produced. Heat is produced, so heat will be released. So I can write here like this also. Okay, heat. You are writing heat like this. Okay, when I write here, the meaning is what? This when these both are reacting, we are getting the heat. Heat is released. Okay. If for example, if you want to provide the heat, means when for example, you say calcium carbonate, CaCO3 is there. Okay, CaCO3 on heating, it splits into calcium oxide and carbon dioxide. To make this reaction more informative, what we do is calcium carbonate is solid. On heating, so you can write here heat or heating, or you can write a symbol like this delta, means triangle symbol. So it shows that here we are heating. Like this, you should make more informative. Okay, so we are getting calcium oxide here, so that is solid. You know that carbon dioxide is a gas. So like this. Clear to you? Okay, so like this, you have to make the chemical equation more informative. So I would write their states, in which state they are existing. Okay, and whether the chemical, to take a chemical reaction, we need to supply the heat or not. Okay, we have to check. If you need to supply the heat, then you have to put here on heating. So this symbol for heat. Otherwise, you can write like this also. Okay, you can write here like this also, CaCO3. Okay, plus heat means what? We are heating, so that we are getting the calcium oxide plus carbon dioxide. Okay, so like this also you can write, but the best way is this method. Okay, just put the symbol this one. Right? So these. Okay, so this making the reactions equations some more informative. Like, okay, so here solid, gas or liquid, and whether we are heating or if that both are burning and they are giving the heat. So I think you know already we discussed somewhere like exothermic and endothermic reaction. The reaction which takes place by taking the heat, they are called endothermic, and the reaction when they burn or doing something, if it is releases heat, that is called exothermic reaction. This already we discussed, I think, in somewhere. So endothermic and exothermic reactions. This is all information you have to put while writing the chemical equation. So students, remember here, as it is, if you write element to element, okay, without balancing, then this is called a skeletal equation. Okay, and if you balance, and this is called balanced equation. And whenever you write in the examination, you need to write the balanced equation with states, okay, like this, solids, gases, okay, you have to mention, you have to make as much as more informative the reactions. Clear to you? Okay, so with this, we stop today. The class timings, okay. So with this, we stop today. Meanwhile, once you check here the practice sheet, page number 73. Once you can see the page number what is that? 73. So first one, say a balanced chemical equation does not tell about the changes such as precipitation, change of color, evolution of heat, all of this. If you write just the equation like this, you don't get any information. Okay, you need to write information about that one. So the answer is 4. The the substances which take part in chemical reaction, which are taking part in chemical reaction, means left side. Okay, they are called what? Reactants. So answer is what? Reactants. The substances formed as a result. What are the new substances are forming after the reaction? When hydrogen and oxygen reacting, what are the new substances we are getting? Water. When nitrogen and hydrogen reacting, what are new substances forming? Ammonia. What it is called? Product. What it is called? Product. Right. Then come to a chemical equation in which the number of atoms of each element is same on the side of reactants and products. So, if the number of elements, both the sides are same. Okay. 2 nitrogens, 6 hydrogens, 6, both the sides same. Then that's called what? Balanced equation. What is called? Balanced equation. Next, CaCO3 plus 2HCl. It gives rise to what? So, here you need to practice this one. CaCO3 plus what is given here? 2HCl. So, CaCO3 plus 2HCl gives rise to CaCl2 calcium chloride plus H2O water plus carbon dioxide. These are the products will form. Okay. So in the answer, what is in our answer? CaCl2 is there, CO2 is there, H2O is there. All are correct. Okay. All are correct. So answer is 4th option. But in the second option, it is printed as CO3. That's not CO3. That is CO2. Okay. And the balanced equation does not tell about speed of reactions, completion of reaction, physical state. So the answer is D, means all. Okay. So students, you practice this practice sheet today, and more practice, try to practice more chemical reactions and convert into the chemical equations. Okay. So bye. Till now, take rest. Bye.